Hello students, let us solve the third question. The first four terms of a sequence are 3 minus 6, then we have the third term which is unknown, and then we have negative 24. Decide, showing detailed reasoning, whether the sequence could be an arithmetic sequence, a geometric sequence, and for each part we need to find the value of the third term if such a sequence is possible. So first let us check if it is an arithmetic sequence. We are given the first term is 3, the next one is negative 6, the third term is unknown, and we have negative 24. So if it is an arithmetic sequence, it has to follow the general formula a plus n minus 1 multiplied by d. So here our a, the first term is a, and then if this is a arithmetic sequence, then we have to subtract 9, so that will be our common difference. Okay, now for finding the third term we need to put n is equal to 3 in this equation. We will be getting the third term, so we have a, which is 3, and n minus 1 multiplied by negative 9, so that is equal to 3. Then we have plus 2 times negative 9, that is equal to minus 18, so 3 minus 18 will give us negative 15. So this is our third term, that is negative 15. So if I'm going to put negative 15 for the third term, we have negative 15 over here, and this is consistent, right? So because when we subtract 9 over here, we are getting the next term, again we are getting the correct term, again we are getting the correct term, so that is consistent. So this can be arithmetic. There is nothing wrong in saying that this sequence is arithmetic sequence. Okay, now let us try the same with, if it is possible to express it as a geometric sequence. This is our expression, and for geometric sequence we know that the nth term is equal to first term multiplied by the common ratio to the power n minus 1. So here the common ratio is the term which we multiply the first term to get the second term or the next term. So here r is equal to negative 2, the first term is equal to 3, and if you want to find the third term, we put n is equal to 3. Okay, so for n is equal to 3, we have first term multiplied by negative 2 to the power 3 minus 1. So this is equal to 3 times negative 2 to the power 2, which gives us 12. Okay, so the third term is 12 here. So when we write the series, we have 3 minus 6, 12, and negative 24. So we are multiplying by negative 2 here, again by negative 2, again by negative 2. We are getting the correct term because 3 times negative 2 is minus 6 times negative 2 is 12, and 12 times negative 2 is minus 24. So in both the cases, this also is like it can be considered as a geometric sequence. Here it could be considered as a arithmetic sequence. Okay, so both are possible. So let us go through the mark division also. So it is divided into 3 marks, 3 for the arithmetic one and 3 for the geometric one. So if you find out the correct method and find out the value of the common difference and also prove that this consistency over here with the third term, this would give you 3 marks. The same over here, if you find out the common ratio, you'll get the first mark. The common ratio carries the first mark, and if you prove that it is consistent, that is another 1 mark, and for this one, the third term, you get another 1 mark. So this is how the 6 marks are distributed for this question. Now in the last part, we are being told to consider this sequence as a periodic sequence with the period 4. With the period 4 means it repeats, the same thing repeats after 4 terms. Okay, and the sum of the sequence up to 50th term, from starting from 1 to 50, that is equal to 141. We need to find the value of the third term. Okay, so again it is an unknown sequence that we are given right now. So that is 3 minus 6, so u3 and 44 or minus 24? Minus 24. Okay. So I'll just go through what is the periodic sequence again. So U1 is 3, U2 is minus 6, U3 is unknown, U4 is negative 24. Now this will have the same value of U5, again U6, U7, U8. Okay, like that. We are given that the sum of up to 1 to 50 terms is equal to 141. Okay, the sum of I is equal to 1 to 50, U of I is equal to 141. Now this, you can see that up to, these are multiples of 4. The closest number up, which is a multiple of 4, is 48. And then we have U49 here, which is again equal to that. And this is equal to U50. Okay. So we have how many set of periods over here of 4? This would make 12 sets, right? And then this value we know that is equal to 3. This value also we know that is equal to negative 6. So 12 set plus 3 plus minus 6, that is going to be equal to 141. And now let's see how much is one set. So in one set we have 3 plus minus 6 plus U3 plus minus 24. That is one set. Similarly, we have 12 sets like that. So we have 12 multiplied by 3 minus 6 U3 and minus 24. And then we have this plus 3 and minus 6, which gives us 141. So I just rearrange the plus 3 and minus 6 to the other side. So I'll be getting 147, and 144 is equal to 12 multiplied by, now this I can combine. 3 minus 6 is minus 3, minus 3 minus 24 is minus 27. So this is equal to 144. So U3 minus 27, if I divide by 12 on both sides, that is equal to 12. And U3 will be equal to 27 plus 12, that would give 39. So 39 is the correct answer for the third term in case this is a periodic sequence. Okay. So expressing this in the correct format is over here as 12 set and all those things. That is the first method mark over here, and equating that correctly to 141 is another one mark, and the last, sorry, that is another method mark over here, and the last accuracy mark goes for the finding out the correct value. Okay, so I hope it was clear for you. Thank you so much.